All right, guys, we're going to do some factoring review. This was something that I saw students really struggling with. And I know that you want to get into this mode of, oh, I'm solving quadratics. But you really, really need to understand the difference between factoring and solving. So some of you are fine, but a lot of you are still struggling there based off of your Unit 7 assessment. Okay, so factoring practice. So first of all, we have something called the greatest common factor. So the greatest common factor is always what we check for first, no matter what. So if we see like a binomial or something like this, or a trinomial, and they all have the same common factor, that can be factored out. Now, how do you find common factors? So they give an example here of two numbers. So we have the number 18 and the number 30. So we have 18 and 30. So the way that hold on just a second, guys, I apologize. So they look at the number 18 and they say, okay, well, I know that 2 will go into 18. Right, 18 is 2 times 9. And then they say, well, it's not prime factored, so you're prime factoring. That means you're getting it down to numbers that can't divide anymore, like 2 can't divide anymore. It's only 1 times 2. And then I know that 9 is 3 times 3. These cannot divide anymore. And so 3 times 3. There are your factors of 18. Now, your factors of 30. I know that 30 is 5 times 6. And then 5 is fully factored, but 6 is 3 times 2. And so my factors of 30 are 2 times 3 times 5. Now, to find the GCF, they have to be in common in both terms. And so what I see that is in common in both of the numbers have a 2 in common, and both of the numbers have a 3 in common. And then we multiply those back together, and that gives me my GCF of a 6. So I'd like you to try prime factoring. I'm only going to assign the 1 through 4. Okay? I don't want to overwhelm you with work. Okay, next we're going to go to prime factoring, greatest common factor with monomials, right? And binomials and trinomials. So we're factoring out a monomial. So this example right here, we have 12a cubed b plus 15ab cubed. And they give us an answer, but I'm going to go through how they got that answer. So I'm going to do the same thing. I'm going to prime factor. So prime factor. So factor and then write prime if it's prime. Prime means that there's nothing that factors out. All right, so I'm going to take my 12, and I know 12 can be rewritten as 3 times 2 times 2. 4 times 3 is 12. And then a cubed is a times a times a, and b, it's already prime. So here is 12 a cubed b plus, I'm going to do the same thing here with 15. 15 is 3 times 5. A is already prime, and then b cubed is b times b times b. All right, so now after we prime factor, then we find common factors. Okay, well here I see some common factors. The common factors are they both terms have a 3 in common. And remember, if there's more than 2 terms and terms are separated by the addition or subtraction symbol, if there's more than 2 terms, oh, I've gone off the page here. Whoops, let me fix that. So again, 15 was 3 times 5, and then a was prime, and then b was b times b times b. This plus symbol tells me where my terms are. So I have term number 1, and I have term number 2. Now, to be a common factor, it has to be in all the terms. So if I have more than 2 terms, like here I have 3 terms, I have to take out the common factor that is in all 3. So it can't just be in the first 2 or the last 2 or the first and last. It has to be in all the terms. So 3 is a common factor. And then I'm looking for anything else that these have in common, which is an A. So they have an A in common. And then they also have a B in common. Now what you notice is I have 2's here, there's no 2's here. I have A's here, there's no A's here, I've taken the A out. And I have B's here, but I have no B's here, I've taken that B out. And I have a 5, but no 5 here. And so that's like our leftovers. And so that's what's going to be grouped into our parentheses. So we have 4a squared, right? 2 times 2 is 4, a times a is a, plus, bring your plus sign down, and then that would be 5b squared. Now, something that you guys need to do, if you're missing these on a consistent basis, then what you need to be doing is you need to be checking. So you should use the distributive property to check back. So check it. So I'm going to multiply 3ab times 4a squared. So 3 times 4. If you want to do it in a little generic rectangle, right, you can. But it wouldn't look like that. My bad. I get so used to doing the same one over and over again. If you were going to do it in a generic rectangle, it would look something like this, where we would multiply 3ab to 4a squared plus 5b squared. But I'm just going to use the distributive property. So that's 12. A times a squared is a cubed, and b times, there's no b to multiply with, so it's just b, plus 3 times 5 is 15, distributing over, 15a, and then b times b squared is b cubed. All right, so I can check my work back and make sure I've done it correctly. So I'm actually going to assign the evens here, so 2, 4, 6, 8, 10, 12, 14. All right, moving on to the difference of 2 squares. Actually, let me look ahead and see if there's something else I'd like to cover instead. Yeah, I think I want to go to, yeah, I'm going to go up ahead to the 4th one. Or sorry, not the 4th one, the 6th one. I can read Roman numerals. So we're skipping ahead to this guy, factoring trinomials x squared plus bx plus c. And then we will go back to the others, so don't cross them off or anything. I don't want to do all of these in one day. This would be way too overkill for you guys. All right, so to factor a trinomial, I want you to note that there's no value here for a. So a is 1. Right, a is not 0, a is 1. When a is 1, we can do the easy factoring. So this means easy factors. So our steps are identify a, b, and c. Let me make sure you can see where I'm writing. Nope. There we go. Identify a, b, and c. So I'm going to do that. My a value is 1. My b value is 7. Right, here's A, B, and C is 10. Now, something I would like you to do here, your parents, a lot of you have your parents home with you right now, and I know a lot of us have our parents home, but they're busy. But if you're still struggling with factoring, I would like you to sit with your parents and watch this video, or your older sibling, or even a younger sibling. Maybe there's a younger sibling that's just really, math is their strong suit or something. A grandparent, someone. Sit with them and have them watch the video with you. And that might help you. They can help you. Oh, this is where you're getting the step wrong. All right. So step 1 is to identify A, B, and C. A is the number in front of x squared. B is the number in front of the linear term, or x, and C is the constant. So A, B, C. All right, next step. After identifying them, since A is 1, I'm going to do this method, right? So my next step is to find 2 numbers that multiply to A times C, but add to B. So to do that, I'm going to make a little table. So here's my product. They need to multiply to A times C, and they have to sum to B. And in this case, A is 1 and C is 7. So 1 times 7 is 7. They have to multiply to 7 and add to B. I'm sorry, A times C. I just did that wrong. I apologize. They have to multiply to A is 1 and C is 10. So 1 times 10 is 10. But they have to add to B, and B is 7. So we're looking for two numbers that multiply to 10. So we can try 1 times 10, which is 10, but 1 plus 10 does not equal 7. So then we would try the other two ways to multiply. How about 2 times 5? 2 times 5 is 10. 2 plus 5, I apologize about the dog. 2 plus 5 is 7. And so these are my two numbers that I want to use. All right, so step 3. Step 3, the only reason that step 3 is so easy is because A is 1. All right, so step 3, we're just going to rewrite this as two binomials, right? So we're going to have our parentheses, x times x gives me x squared. It's the only way to make 1x squared is x times x. And my two numbers are right here, positive 2 and positive 5. And then the last step, the one that if you're struggling with factoring, you need to be doing, right? You're going to multiply these back. So you're going to multiply using a little generic rectangle. So I'm going to do it up here. So I'm multiplying x plus 2 times x plus 5. So x times x is x squared. X times 2 is 2x. 5 times x is 5x. And 5 times 2 is 10. And then I have anything inside that's alike I can combine, meaning add them. And so x squared does not have a like term. There's no other squares. So x squared is by itself. 2x and 5x, those are like terms. They both have an x. So that's 7x and then plus 10. And if that's what you started with, which it is, then you have factored correctly. All right, so that's factoring easy way. I'm going to do one more, which is factor by grouping. Let me get to that. Okay, so we're skipping ahead to number 8. Factoring trinomials, ax squared plus bx plus c. So you notice what's changed between this one. I want you to use these critical thinking skills to decide which method should I use, right? So the thing that has changed from this example to this example is that here a was blank because a was 1. And here there's an a there because a is not 1. And what you notice is in all of these, right, all of these examples here, a is 1. But what you notice here is that in all of these examples, a is not necessarily 1. And by the way, something that you should always do, if a is 1, there's not going to be a common factor between them all. But if a is not 1, there may be a common factor. So always check for that common factor first. Don't let me forget, not like you can actually remind me, but I need to go back and make sure I tell you which ones of these I want you to do from the other section. All right, so this time a does not equal 1, and so my factoring is not easy factoring. This is the error that you guys continue to make. You will continue to write x times x, but x times x won't give you 2x or 2n or 5n or 10x or whatever it is. X times x is just x squared. If you multiply x times x, you're never going to get a constant in front. So when we have a leading coefficient, which is, right, that's what this is called, factoring with a leading coefficient, we must do what's called factor by grouping. So our beginning steps don't really change. We always check for the GCF first. So we check to see, is there anything that they all have in common? So I'll go back to the first page, which was, they're stuck together, I apologize. right here, right? So check this first, see if they have a common factor, and then factor that out. If they don't, then you're going to move to step 2. All right, so what I notice is that in this case, there is no common factor that all 3 terms have in common. This is 2 times x times x, 5 times x, and 3. There's nothing in common in all 3 terms. So I'm going to move on to the next step. So the next step would be, number 1, identify A, B, and C. And this is, if you do this step first, this will tell you, hey, do I need to factor by grouping, or do I need to do the easy factoring? So in this case, A equals 1, B equals -5, watch out, those signs matter, and C equals -3. I'm sorry, A is not 1, A is 2. I don't know why I said A is 1. I apologize. A is 2. So we've got 2, -5, and -3. Okay, so our steps don't really change that much. Our next step is going to be, we're going to find 2 numbers who multiply to A times C. And add to B. So I'm going to make my little table. My product needs to be A times C, which is, in this case, 2 times -3, which is -6. But they have to sum to B, and this time B is -5. So I'm going to think of all the ways I can multiply to -6. I could have -2 times 3, or 2 times -3. I could have 1 times -6, or -1 times 6. And then I check my sums. -2 plus 3 does not equal -5. That's 1. 2 minus 3 does not equal -5. That's -1. 1 minus 6, 1 minus 6 is -5. So here are my 2 values. Now, I'm going to show you the common error. So I'm going to show that off to the side on a separate sheet of paper. Okay, so here's what I keep seeing happening. So we think, oh, here's the numbers. So then it is x minus 6 and x plus 1. Done. Now, if you guys were checking your work, you'd see there's no way that's true. If you multiply here, you get x squared. That's positive 1x, negative 6x, minus 6. You get x squared minus 5x minus 6. Let's look at our original. Is this what we had? No, it is not. So that is an error. So you need to stop making that error and listen up. Because A was not 1, we have some different steps. So step 3, we're going to split B into the numbers from the table. The numbers I'm talking about are 1 and -6. So I'm going to rewrite my trinomial, 2x squared, and my last term C was -3. And you notice I'm only changing B. So A and C stay the same. And what's going to happen is I'm going to use these 2 values to rewrite -5x. So I have positive 1x minus 6x. This is still -5x. And the reason that I'm doing that is because I want 4 terms. Because I'm doing something called factoring by grouping, which means I'm going to group them or pair them. And I can't pair 3 terms, but I can pair 4. All right, so I'm going to split it and take out the GCF of this side. So the next step, 4, split and take out GCF of each side. So I'm going to split, take out the GCF. So the GCF here, they have an x in common. So I'm going to take out an x. If I take an x out, I'm going to actually do this a little slower for some of us that are still struggling. what you should see that they have in common is this x, and so that's going to pop out. So that's the x that's outside. And what's left over in the first term is 2x. And what's left over, bring your plus sign down, in the second term is 1. All right, now I'm going to look at the other side. Whatever sign this is, please place it right there. Okay, now I'm going to factor this. So I've got negative 2 times 3 times x, and then minus 3. So what I see that they have in common is a 3. Right, my two terms have a 3 in common. So I'll bring out a 3. And then remember, I always, since I factored out a negative, I have to be very careful. I always make sure that if I factor out a negative, that this sign is going to switch. Because if I do a negative times a negative, that would give me a positive. So I have 2 and x left over. Remember, I took the negative out. And here I took the negative out, so this will switch signs and become positive. Well, what's left? I can put a 1 here. So that'd be positive 1. And then you can check it back. 3 times 2x is 6x, and a negative times a positive is a negative. 3 times 1 is 3, and a negative times a positive is a negative. All right, the next step, this is where we're going to split it again. So split again. And take out the GCF. So the GCF here between these two, they both have a 2x plus 1. So that's going to come out, 2x plus 1. And then in this term, what's left over is an x. So to get this term back, I'd need an x. And in this term, what's left over is a minus 3. So to get this term back, I'd need a minus 3. And now the last step is to check it. So I'm going to multiply it. This time I'll do it in a generic rectangle. Make sure that you're not off the screen. No, you can see it. Okay. So I've got 2x plus 1 times x minus 3. So x times 2x is 2x squared. X times 1 is x. Negative 3 times 2x is negative 6x, and negative 3 times 1 is negative 3. Again, here's our like terms, so I can combine these. So I have 2x squared, that can't combine with anything. Negative 6x plus 1x is negative 5x, and then minus 3. And that is what I started with right here. So you can see the difference between this answer and this answer. They're very different. All right, so now, so I don't forget, I'm going to give you guys, for this, I'm going to give you guys the, I'll just stick with the evens, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And I'm going to do the same thing on the previous one. So the previous one where A was 1, evens 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20, and we'll go ahead and add 22. All right, please try to do these on a separate sheet of paper. You can see there's not a lot of room here. If you can put it in here, these ones aren't too hard, but if you have enough room, you can. I'm just saying it's a lot easier for me to read if you put your work on a separate sheet of paper. Please do your work on a separate sheet of paper. Put your final answers here. That helps me to see, oh, look, they did them all, yes. And I can just quickly check them. And then please provide your work on a second image. Thank you very much. So I'm going to recap really quickly. So we've got factoring practice. You're doing number 1, number 2. Number 1, you're doing 1 through 4. Number 2, you're doing evens. And then you're also going to do number 8, evens, and you're also doing number 6, the evens. All right, guys. Come into my Zoom if you need anything. If you're still struggling, you have questions on anything. This is a super important topic for next year. You have to know how to factor by grouping. Have a good night. Bye-bye.